Okay, I'm going to pick up some of the threads that we just heard of, and that is how can we value soils, and how can we value the capital that we can see in it. And I'm going to address it from a question which is very important nowadays, and that is, just as you said too, how can we feed the world? How can we look at yields that we have today, and can we improve them? We know that we need to do that in some way or another, either increase area or increase yields, and to that that is called a yield gap. So I'm going to go through and see my view on this. And I think I'm doing the right way here. Okay. Agriculture and yield gaps, then we have all these new global demands. We need food, but we don't only need that, but there's also a conflict to natural areas that we need to preserve. And we also have now an increasing production of biomass across the world. And even though we might not do it in Europe all the time, then we export this to other countries in the world. So on a global scale, this is really ongoing, even though we might not see it here in Europe as well. And this yield gap, which we then can define as the potential production which is possible in the future, minus what we have now. The reasons for this, they say, how can we fill the yield gap, which is the kind of the general discourse at the moment. And people say, well, the soils that you can realize that they have a yield gap, they have a fertilizer limitation, which means that it's not the soils are not limited by fertilizer. It means that we don't add enough fertilizers. So by adding more fertilizers, we can then fill the gap. Others is a lack of water. So with irrigation, we can then fill the gap. And a third important factor is that we have also very variable yields, and especially the more water problems, the more variation in climate, we will see even more variability in yields in the future. And here people also talk about adding more fertilizers, or even giving incentives or paying for insurances for the farmers. But this is not really sustainable, not anyway to me. I think each of these factors will maybe increase the yields for the farmer, and we will have more food, but we will certainly also have more environmental problems at the other end. So I'm going to tell a story here that we call the natural capital, which is valuing what I say is the invaluable. And can we use this concept to work for valuing soils and the functions from soils in a way to send messages, and to do this to investment banks, to farmers? And can we by this way maybe increase the yield, or fill the yield gap and increase the yields? And sometimes I feel like I'm in a mission on this, but here, we are all believers in this, I guess. That's why you're here now. So we know that we have this tremendous soil biodiversity that is, by their actions and interactions that we heard about over these days, feeding, digging, nitrifying, we have all these services or functions that when we use them as humans, we can call them services, and they provide us with the food, feed, fiber that we need. And if we then look at what's the consequences of this then when we have the production? So I have a map of Europe here, where we at the right side we can see the current wheat yields in Europe on average for this statistical regions in Europe, and we can see that in the northwestern Europe we have quite good yields. And according to the yield gap, that those who analyze yield gaps, they say, well, we're almost there. Maybe we're on 80% up to the potential yields. While in Eastern Europe and more southern parts, where there's still a gap, and those they plan to fill by increasing fertilizers and having heavier irrigation. Also, when we look at the soil organic content in Europe, we can see that we also have in Eastern Europe, we have much, much lower carbon contents than in some of the other parts, and usually the more intensive we go, the less carbon we have. So I'd say we plow away all the carbon in our soils eventually. which also have effects on the fertility of the soils and on other environmental factors. So how can we then value this? So we say, what's the value of the soil natural capital? Well, the value is different on what side of the farm gate you're on. So if you're the farmer, you might say that the value of soils, you need a fertile soil, that's really good. That can retain the water in the soil, just as we saw in your pictures. And there will be less erosion, and then the farmers can also use less fertilizers and pesticides. And that will also cascade another value to society, which is reducing all the environmental problems at the source instead of, as we do today, we try to mitigate them when it's already happened. And valuing these different parts demands different techniques than scientifically in economics. And I think the value to society we heard about Kate a bit on today, how people perceive the value of these services. There are also techniques where you can put money on it, but I'm going to more deal with the value to farmers here now, because this is a good way of persuading farmers to farm their land in a sustainable way. And when we've been working, we've been addressing what we call a decision loop. So you work, if you go clockwise, you're around 2 o'clock here, you can see that we have this base of the services that we can influence how you manage, and they provide functions and services which we then can value. And the value of these can be sent into information to other sources where decisions are taken. Anything from the local within farm gate or to the societies or global decision makers. And that loop can run around. It can be iterated on local scales and global scales and in different times and so on. But have it as a mind loop. Okay, so I'm going to do some quick results from an EU project we had where we worked with looking at intensity of agriculture in 4 regions in Europe, and where we also valued ecosystem services. And when we worked here, we could see that the diversity, if you look on the right-hand side, that the diversity within the food webs decrease over these 3 land use intensities from grasslands to intensive wheat production. And we also have a soil carbon content which is decreasing. This is not rocket science, but we needed this relationship to be ordered in order to be able to enter economy. Because when we started to work with the economists, we had we had thousands of species, and we had fluxes of nitrogen and carbon, and we said, can we put this into your economic model? And they said, maybe not. So this is we had to find an interface, and the interface we have been using is the soil carbon. So I'm going to use soil carbon as a proxy for diversity and services. It's not the soil carbon itself which gives the value. That's the organism, as we all know. But this is a way of being a bit general, but still being based in the real actions. So what we did was to start to value how soil diversity and then soil carbon can increase yields for the farmers. Every farm in the world knows this, but they can't put a number and money, an amount of money on how much. So what we did was to look into a number of long-term experiments running for at least 50 years across Europe. And this is from one of the experiments where we had a range of carbon from 1% to 3%. And you can easily see that if you add 90 kilograms of nitrogen and you have a low carbon content, you will have a lower yield than when you have a higher carbon content. This is, of course, a variable between fields, but as a relative scale, this works. So in a way of having this, we call them production functions, because we can estimate the rate of how much carbon which is in the soil into the yields of the farmers. And looking into several of these sites across Europe, we can see that the relationship on these, and they are fairly general, even though we are in other countries. And by having a higher yield per hectare also means that we don't have to apply as much nitrogen, so we can reduce the fertilizer application and still get higher yields. And when we do a full economic model for the farmer, we can also see that the profit for the farmer increased tremendously if they have a relative increase of carbon. And how can we then use this knowledge? Well, we looked into a number of different types of land management across Europe and in other countries in the world too. And if you look at the relative rates of carbon decline, which also will be correlated to relative rates of biodiversity decline, we can see that generally in normal farming, we have a decline rate from 1%, maybe down to 0.3 or 0.2%. And this is not only in Europe, this holds also for the US and Australia, for example. And to increase the carbon content by, let's say, 0.2% per year, you need to add something. You either need to have a permanent plant cover or to add back the straw and so on. But by using these numbers, we can now enter these into more dynamic modeling of the economy of the farmer, because if you tell the farmer, yeah, well, if your soil if you have a soil by 1% carbon and it increases by another percent, which means, 100.1, it's not measurable and you can't measure his profit the next year. So you need to show that this is a really long-term process. And what we've done then is to just apply normal financial economics. So this is interest, you have a mortgage on the bank. Either you pay your mortgage every year or you have your savings account where each of your euros is increased, and it's increased exponentially. And this is the same way with our soil biodiversity and soil organic carbon. And what we did now is that we are starting to try to do a production model of Europe where we take into account fertilizer rates, carbon rates, and yields, and then we apply the different types of rates of change for a number of crops. And this is very much ongoing, so I just have made some general maps of wheat. And if we will continue to grow wheat as we're doing now, we will have a decrease of the yields of wheat across Europe and not filling the yield gap. We will increase the yield gap instead. But if we would increase the carbon by maybe 0.5 or down to 0.3% per year, we will have a tremendous increase instead, and not adding anything more than just promoting this carbon to grow, to increase exponentially across 20 years. And these yield gaps, as I said, both we talk about fertilizer applications, and I haven't really talked about irrigation, but risks. I think this is where the soil biodiversity comes in at most. As you have here, we have here a very important tool to show that yes, we can mitigate climate change by putting down more carbon and increasing soil biodiversity into the soil. But what can we do? Can we do anything on energy prices or crop prices? They are generally correlated. But if the farmer can have a more predictable yield the next year, it will also mean that it's easier for them to plan things, investments, and they don't have to pay a very high mortgage one year because they didn't get the wheat yield they wanted. So some farmers will really be risk reducers, and other ones might be, take the risk. Just as any one of us here, maybe some of us are maybe real gamblers, while other ones say, I want to know what my future looks like the next 20 years. And so we've been working with this, and I'm just going to show you very generally here into figures. If we look at the variance in profits of the wheat yields across some of these data sets, you can see that this is real data, and we have a general normal distributed peak but we have a long tail, up to the right, of having the profits increasing. And that might attract some of the farmers that, yes, if I do this, I might get a very, very high yield in the short run, but not in the long run. So what we did was that we've been trying to then look at the value of the natural capital. And the natural capital is then, that's the soil biodiversity. And here are these 4 countries that I showed you the results of before. And the risks we take is the same thing as saying that we are discounting away future problems. And if I take a loan this year and I'm going to pay it off within some years, it might not be worth anything in 20 years. You know, or if you have a house and you buy it, and it might be worth a lot in 20 years. So, but here comes the difference whether we are risk-prone. So if we have a high risk, we then discount away potential profits, which means also that we will not care about preserving the soils in the future, because we are really more after the profits that are very in short time. And on the other way, if we have a more low risk, we will consider a discount rate on which is much lower, so then it's worth to do long-term investments. And so, my message, if we can reduce this gap, I think we should invest in soil capital. So, thank you.
Any question? Over there.
It's a very interesting talk. I was wondering, did you also look at the actual yields of particular fields and correlate it with the organic matter content? And do you then also see the same, that, for example, on fields where you have organic matter concentration of 1%, that you always have a very low yield despite high fertilization input, etc.?
You know, you have to regard these as relative changes in carbon, because you might have a field, some of these sites are very, very productive, but have initially low carbon contents because of geological reason, you know, historical, since the deglaciation. And so these are statistical models. You can't say that you will always get a lower yield when you have 1% than a field with 2%. But if you have a field with 1%, we can estimate the increase of yield when you go up or down, or decrease when you go down. Okay, was that an answer?
Yeah, that's a good answer. I have a second question. So we're working also for organic farmers, and we're trying to convince some conventional ones to also change to organic farming, which includes having, for example, a pasture, grass clover pasture for 2 years, which basically means you cannot grow wheat for 2 years. So what are your answer to these kind of conventional farmers who basically then lose 2 years of yield, but they build up the organic matter pool in their soils?
Yeah, that was the figure I took out this morning. But if you have a grass pasture for 1 or 4 out of 4 years, that was in our example, your soil will still be declining in carbon. But if you do it as an 8-year rotation and you keep the grassland for 2 years in a row, you will have an increase of carbon. And so we've done models where we put this 1-year grass lay within the crop rotation, and even though the farmer doesn't get any profit from this, within 15 years the profit of the farmer will be the same, because carbon is reduced in the business as usual case, and when they're still not having an income from the grass lay, it will even out at the end. So you're perfectly right with that.